the fourth lecture from chapter number 9. In this lecture, we are going to study the impact of aspect ratio of an nMOS transistor versus VOL for a pseudo nMOS node. We know that for a pseudo nMOS node, it consists of one PMOS transistor that is always on and one nMOS transistor to which we apply the input. And we have seen that VOL is not 0, but it is greater than 0 in case of n, which is undesired. We want this nMOS, we want this VOL to be exactly equal to 0 as it is in case of CMOS. So one possible solution is to increase the aspect ratio of nMOS transistor. That will bring VOL down to nearly equal to 0, but at some expense. So in this lecture, we are going to see what that expense or cost is. Right. We have studied that VOL, this expression was studied by us in lecture 9.1 for a pseudo nMOS node. This is the power supply voltage, the threshold voltage for nMOS. This is beta P device transconductance for PMOS, device transconductance for nMOS. Beta P can further be written as kappa P times aspect ratio of P, and beta N can be written as kappa N aspect ratio of N. And this is the threshold voltage for PMOS. In order to see what is the effect of increasing aspect ratio of N over VL, we keep everything else fixed. We keep VDD 5 volts, VTN and VTP both 0.7 volts, kappa N 150 microampere per square volts, kappa P 60, and even aspect ratio of the PMOS transistor that is always on is also fixed. So what we are going to do, we have only one unknown, that is aspect ratio of N, that is a part of beta N. Beta N is, we know, is kappa P, sorry, beta N is kappa N times aspect ratio of N. So in this equation we have kept everything else constant and will vary aspect ratio of N, and then we'll see what is the effect of that on VOL. Let's go ahead and vary aspect ratio of N. Put that value, for example, we have put it 1 to start with. We have put 1 here. Beta N is kappa N 150 times 1. Everything else is constant, remains the same. So VOL is 2.37 volts. And then we have put a larger value of aspect ratio of N, that is 1.5. So we see VOL decreases. Increasing the size of the nMOS transistor further decreases VOL. And this process goes on, and we are getting decreased VOL as desired, but at the cost of increasing aspect ratio. Why do I say that it is a cost? So for 5, we get 0.35, a pretty good VOL. But this is the cost. Why is this the cost? Because increasing aspect ratio means consuming more space on IC, which has some cost. So in short, it's a compromise. If we plot this VOL versus aspect ratio of n, we see that as we increase aspect ratio, VOL decreases almost exponentially. So what we want is we want a small value of VOL, but we don't want the large value of aspect ratio of n. This means, and if we want a small value of aspect ratio of n, we get a larger V. So we are in a trouble. So we have to make a compromise somewhere in between, where we can have a bit larger in the middle, aspect ratio of VOL in the middle, and the aspect ratio of VOL in the middle, and aspect ratio of n in the middle. So we must make a compromise somewhere in between. We cannot get both goods at the same time. Either we can have a smaller aspect ratio of n, or we can have a smaller value of VOL. But we cannot get both advantages at the same time. It's a compromise. Like many other things in your life, it's a compromise. I have also done a small exercise for you in Microsoft Excel. I have plotted this VOL. Actually, this column implements this expression, this whole expression, with while taking aspect ratio of n from this column. And we see that it decreases as VOL decreases as we increase aspect ratio of n. You can also play with this file. I can share it. I will share it on MS Teams as well as in your WhatsApp group. You can put different values. For example, you can put a value maybe 9.5, maybe you put a value 9.7. So you get a different value of VOL. You can try different, maybe 1.2. You get a different aspect rate. You get a different VOL. Maybe you got 2.1. So you can try. You can even go ahead. You can go ahead and try even larger values of aspect ratio, and you'll see this VOL will keep on decreasing. But this is the cost. This greater aspect ratio is the cost that we have to pay. We will be studying more about high-speed VLSI logic schemes in our upcoming lectures. Thank you.